we're going to start talking about matrices. Now, we are not abandoning our systems of equations. We are actually going to go through working with matrices so that I can show you a very efficient way that we can solve matrices. Now, when they're fairly simple, stage 1, stage 2, stage 3, we can do those by hand, no big deal. We will utilize matrices to solve those as soon as we learn the basics of our matrices. Now, matrices, you're going to use matrices to organize and represent data. You're going to identify the order, which we talk about identifying the dimension of a matrix. We're going to add and subtract matrices. We will multiply a matrix by a scalar multiple. And eventually we will create augmented matrices, and we will use these matrices in our graphing calculators as tools. First of all, I want you to know you're going to have these statements to make. So in your journals, you're going to put, I will use matrices to organize and represent data. I will identify the dimensions and elements of a matrix. I will add and subtract matrices, multiply matrices by a scalar multiple, and you're going to create matrices to solve systems of equations. We're not going to do all of these today. As a matter of fact, we'll do the majority of this today. We will organize and represent data. We will talk about the dimensions and identifying the elements. We will talk about adding and subtracting matrices, and we will talk about multiplying matrices by a scalar multiple. As soon as we get all of those down and good and steady, then we will create matrices to solve systems of equations. Now, what are matrices in math? What are they in? What do we use them for? Well, they're a set of numbers arranged in rows and columns as to form a rectangular array. So you have a rectangle, or you could even have a square. You can have a square matrix. You can have a rectangular matrix. Either way, the numbers are called the elements or the entries of a matrix. Now, these are matrices. Matrices are classified by their dimensions. Their dimension are rows. Rows are horizontal, columns are vertical. So these right here, these right here are rows, and these here are columns. So we have 3 rows by 3 columns. This is a square matrix, so this is a 3 by 3 matrix. So if you were to just look at this and they say classify this matrix, you classify a matrix by its dimension. 3 rows, horizontal, 3 columns, vertical. Rows by columns. This one here, how many rows do we have? 1, 2, 3, 4. We have 4 rows by columns, 1, 2, 3. 3 columns. Do not mistake this little X as a multiplication sign. It's a by. Kind of like when you go to the store, you have a 2 by 4. It's 2, then you have your little X by 4. You have 4 by 6. Okay? It is the dimensions of the matrix. Now, in a 3 by 3, this A is 1 element, B is 1 element, C is 1 element. So in this particular matrix, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We actually have 3 times 3. We actually have 9 elements in this matrix. This one here, 4 by 3, 4 elements by 3 columns, we're going to have 12. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 elements here in a 4 by 3. We have 9 elements here in a 3 by 3. Every 4 by 3 will have 12 elements. Every 3 by 3 will have 9 elements. Every 2 by 2 will have 4 elements. Let's see what I can do. Every, let's see, a 2 by 2 would be 1, 2, 3, 4. So we would have 4 elements. This is a 2 by 2. Let's do a 2 by 6. 2 rows, 6 columns. 1, 2, 3, 4, 5, 6 columns, 7, 8, 9, 10, 11, 12 elements. So it is important that and they look like large brackets. Again, these are not brackets. They denote a matrix, okay? So we have a 2 rows by 6 columns, 2 rows, 6 different columns. We have 12 different elements in that in particular matrix. Now, matrices can be named as well, okay? They are normally named with a capital letter. A equals QRS, TUV, WXY, Z, AB. So all of these elements are in matrix A. Matrix A is a 4 by 3 matrix. 4 rows by 3 columns. Matrix A has 12 elements. Matrix B, capital letter B is this. Matrix B has 9 elements. Matrix B is a 3 by 3 matrix. Okay, I don't like the way that looks. Let's fix that. So this would be a 3 by 3 matrix. Okay, now matrices are again classified by their dimensions. Dimensions is rows by column. This is a 3 by 4, 3 rows, 1, 2, 3, 4 columns. If you'll notice, I've got little subscripts here. You can't see them real well, but they're a little below. So your first element is A11, first row, first entry. Your second entry on your first row in your first column, first row, second entry. Your third one, first row, third entry. Your fourth one, first row, fourth entry. So your first number here is the row. The second number here is the column. First row, first column, that's the first one in the first row, first column. Here's the first one, first row in the second column. You're in the first row, you're in the second column. First row, you're in the third column, okay? You're in the first row, you're in the fourth column. So either way you look at it, you can classify each of these elements by where they are by the rows and the columns. This is a 3 by 4 matrix, 3 rows, 4 different columns. If we wanted to know what entry was in the, let's say the third row, we want the third row, and we want the second entry, or the second column. We would go to the third row, 1, 2, 3, 3, 2. Third row, second entry. This is what it would be, okay? So that denotes those. Ooh, I think I went too fast. Let's go back one, I think. Yeah. Okay, so we're gonna answer the following questions given this matrix. This is a matrix of numbers. We can have an algebraic matrix like what we had before. These are algebraic matrices, or actually those aren't. These are algebraic matrices. We have variables in for some of those elements, which is no different. We'll gradually work into those. We're going to take this, kind of slow and steady. Okay. This is matrix A. Matrix A is a 3 by 3 matrix. 3 rows, 1, 2, 3 rows, 3 columns, 1, 2, 3 columns. So if I want to know A32, I want the third row, the second entry, or the second column. I go to the third row, 1, 2, 3 rows, second entry, this one right here. So A32 is a -4. -4 is the element in the position A32. What are the dimensions of the matrix? Now, I probably should have chose a different one because our dimension are rows by columns, and we just happen to have a square matrix. We have 3 rows by 3 columns. This is a 3 by 3 matrix. What is the name of the matrix? The matrix is named with a capital letter. This is matrix A. A is the name of the matrix. How many elements are in the matrix? Well, it's a 3 by 3. We can take 3 times 3. We have 9 elements, or you can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Last but not least, I want, what is the element? 8, 2, 3. Second row, third column. Second row, that's this right here, third column. 1, 2, 3 is 7. So A23, so the element A23 is the element of 7. You will have to answer questions like this. You will be asked to answer questions like this, okay? Next. Okay, matrices are classified by their dimensions. Dimensions are rows by columns. They can be square, 3 by 3. They don't have to be square. They can be a 4 by 3, a 6 by 2. They can be 1 row and 5 entries. It could be a 1 by 5, okay? But again, M is your rows, N is your columns, and M by N, or rows by column. Each entry in a matrix is called an element, okay? We can add or subtract matrices only if their dimensions are the same. A 3 by 3 can only be added to or subtracted from another 3 by 3. A 2 by 2 can only be added to or subtracted from another 2 by 2. A 4 by 3 can only be added or subtracted to a 4 by 3. A 2 by 6 can only be added or subtracted to a 2 by 6. So my dimensions have to match. I cannot ever take a 2 by 3 and add it to a 3 by 3. The dimensions are the same. One's a 2 by 3, one's a 3 by 3. They do not go together. We can only add or subtract matrices if their dimensions are the same, are equal. So we need to remember that, okay? So we're gonna do some of these. Oh, that one I might have to scoot over. Now, this is a 2 by 2, 2 rows, 2 columns. This is a 2 by 2, 2 rows, 2 columns. Easy peasy, a 2 by 2 added to a 2 by 2. My result will be a 2 by 2. It's very, very easy. So I take the first row in the first column and I add it to the second row in this, or I'm sorry, first row in the first column and I add it to the first row in the second matrix. So this one matches up with this one, okay? So I literally take 5 plus a negative 3. I'm going to take 0 plus a negative 6. I'm going to take a negative 5 plus a negative 1. And last but not least, I will take a negative 3 plus a negative 3. I'm going to show all of that work. I don't necessarily have to, and I wouldn't ask you to do it all, but I do want you to be very cautious, very careful. So, showing all of my work, I'm going to write kind of big here, and I'm probably going to have to erase and come back. I'm going to have, and I'll do it in blue, I'm going to have a negative 5 plus a negative 3. That's the first entry in the first row for the first column. My second one would be, I got green, I've got 0 plus a negative 6. This is a plus a negative 6, something like that. Do it again. 0 plus a negative 6. There we go. And then on my, and I guess I didn't need quite that large. I can make those a little smaller, give myself some room. Oh, flicking flat. There we go. Okay, so this next one would be a negative 5 plus a negative 1. And my last entry would be a negative 3 plus a negative 3. So I'm just showing you what I'm doing. And my answer would be, and I'm going to put it all in green, a negative 5 plus a negative 3 is a negative 8. You owe somebody $5, you borrow $3 more, you owe somebody $8. 0 plus a negative 6 is a negative 6. You have no money and you borrow $6, so you owe $6. A negative 5 plus a negative 1 is a negative 6. You borrowed $5 and then you borrowed 1 more, so now you owe $6. A negative 3 plus a negative 3 is a negative 6. You borrowed $3 and then you borrowed 3 more, so now you owe $6. So your answer, this matrice plus this matrice is this. So negative 5, 0, negative 5, 3 right here, plus negative 3, negative 6, negative 1, negative 3 will yield or will give us a result of a negative 8, negative 6, negative 6, negative 6. I really don't like that because it looks like we could have added almost anything, but we didn't. Notice I color-coded those. Now, I will scroll over here. Thank goodness my things. Goodness. Let me come over here and move that just a little bit. so we can see it a little better. Now on these, okay, subtraction can be a little tricky. So what we're gonna do each time, every time, all the time, is we're actually going to make it into an addition problem. We're gonna add the opposite of everything to the right of that matrix. That means I'm gonna add a positive 5, a positive 2, a positive 2, and a negative 2. I'm going to add a positive 5, a positive 6, a negative 5, and a negative 1. So now I have an addition just like I did this other one. And you know, I kind of went a little too fast. I should have made note. First of all, this is 2 rows, 4 columns. This is a 2 by 4, and this is also a 2 by 4. So I know that I can subtract these. Because I know that I can subtract them, I made it into an addition problem. And now I'm going to work this one exactly like I did the first one. And I will show all my work, okay? I don't have enough colors to color code it, okay? But I'm going to have a 6 plus a positive 5 in the first. Then I have 1 plus 2 in my second. I have a negative 1, let me change my colors. A negative 1 plus 2. This negative 1 goes to this 2. And then I've got 3 plus a negative 2. So I took 6 and added 5, 1 and added 2, negative 1 and added 2, a positive 3 and subtracted 2 because I made an addition problem. I'm going to do the same thing on the bottom row. I'm going to color code these again. I'm going to take 2 plus 5, 2 plus 5 here. I've got a negative 4 plus, and let's make that look like a negative 4. Negative 4, there we go, plus 6 right here. And then I have another negative 4, and I'm going to subtract 5. And then last but not least, I've got a negative 6 plus a negative 1. And now what I'm going to do is I'm going to simplify that. I'm just showing you all of my work. And if you don't show your work, I cannot identify what error exists if you made an error. Okay? I can't find out what's up here, but I can look at your paper and see what we did incorrectly. So here we go. We're going to add our answers. 6 plus 5 is 11. 1 plus 2 is a 3. Negative 1 plus 2, I owe somebody $1. I have $2, so I still have $1. I have $3, but I'm going to spend $2, so that means I only get $1. Okay. 2 plus 5 is 7. Negative 4 plus 6. I owe somebody $4, but I have $6, so that means I get to keep $2. I owe somebody $4, and then I borrow 5 more. Negative 4, negative 5 gives me a negative 9. And then I have a negative 6 plus 1. I borrowed $6 and then borrowed $1 more, and now I owe 7. So again, 2 rows by 4 columns. I can add or subtract those, and I'm going to get 2 rows by 4 columns as my answer. So 2 by 4 plus a 2 by 4 will yield a 2 by 4. Okay? Now, let's come down here to this one. Whoops. Right here, I have 3 rows and 2 columns. This is a 3 by 2. And they're wanting me to subtract a 2 by 2. Okay? This right here is undefined because we can't do it. It is not possible. So if we should ever get whether we're adding or subtracting isn't relevant, because if the dimensions aren't the same, we cannot add or subtract. If we cannot add or subtract, this is undefined. So the answer to an equation or a matrix equation like this, you can't do. Your answer would be undefined. And if you were asked to support that, why is it undefined? Well, this answer is undefined because you cannot add or subtract a 3 by 2 to a 2 by 2. The dimensions are different. In order to add or subtract matrices, the dimensions have to be the same. Okay? Now, Now we've talked about adding, we've talked about subtracting. Let's talk about a scalar multiple. A scalar multiple you should have, I said should have, didn't say you did, should have been introduced into that with geometry, okay? When you were doing dilations, you made something larger or smaller. You could do that by setting up a matrix, okay? And you could do that with a scalar multiple. Now, right here, a scalar multiple, what this is saying, and I don't like the way that this is out here, I'm going to move it down just a little bit, okay? So what this is saying right here is I'm taking a -3 and I'm multiplying to this matrix. Now, first of all, let's talk about this matrix. This has 3 rows, I have 4 columns. This is a 3x4 matrix. I can take a scalar multiple and I can multiply to any size of matrix I want. I don't care. I'm going to take that -3 and I'm going to multiply it, and listen, this is a 3x4, so I'm going to do it 12 different times. I'm going to take this -3 times the 5, this -3 times the -4, this -3 times the 3, this -3 times the 12, and then I'm going to repeat the entire process. Now, I'm not going to write all of that out. We are simply going to answer the question, okay? -3 times a +5 is a -15. A -3 times a -4 is a +12. A -3 times a +3 is a -9. A -3 times a +12 is a negative. There we go. I got to go away. Sorry about that. Okay. -3 times 12 is a negative. Didn't get my 36 down. I hit something instead. Now, second row. Okay, I'll do color code. -3 and -15 is a +45. -3 +2 is a -6. -3 times 0 is 0. -3 times -11. Negative and negative make for a positive. I'm going to get a +33. -3 times a +10. Again, last row. -3 +10 is a -30. -3 times a +1 is a -3. -3 times a +27 is -81. A -3 times a +4 is a -12. So, -3 times this matrix will give us this resulting matrix. Anytime we multiply by a scalar multiple, we still are going to have the same dimensions. This was a 3x4. I still have a 3x4. 3 rows, 4 columns. So I literally distributed. That's all you're doing is distributing, multiplying that 3 to every single element in that matrix. Okay? So we can, again, scalar multiples are easy peasy. Okay? Now, we're going to do some practice problems over here. And these are kind of big. Let's see if we can't make those just a little bit easier to manipulate and read. Okay? We're going to do this one. Let's get this one up here. I'll do this one. Okay, bring that up there. Okay, we'll just do those and we'll scroll down. We might resize those. Okay, so here we go. First of all, first thing I'm going to check. Are my dimensions the same? Because I don't want to waste my time. You know me. I'm always about quick, simple, and easy. This is 2 rows, 2 columns, 2 rows, 2 columns. I can totally add these together. So I am going to do that. -6 plus 1 is going to be a -5. A -1 plus 4 is going to be a +3. 0 plus 2 is going to be 2. -1 plus 5 is going to be a +4. So my resulting matrix, when I add these 2 2x2s, I will get a 2x2 matrix. And this will be the result that I get. I take the first row in the first column over here, add it to the first row in the first column. First row, second column goes to first row, second column here. Second row, first column goes right here. Second row, first column adds to that. Okay, we just repeat the process. Again, on this one, that's a subtraction. So I'm changing it. This is a 2 rows by 1 column. This is a 2 by 1. 2 rows by 1 column. Okay, I don't like that. I think I'd do better here. 2 rows by 1 column. 2 rows by 1 column. I absolutely can add or subtract these. So I'm going to make an addition problem by adding the opposite of everything. My resulting matrix will be a 2 by 1, 2 rows, 1 column. 4 plus a negative 2 is 2. 2 plus 5 is 7. Ta-da! I'm done. These are easy peasy. Don't get in too big of a rush. We're not going to do 30 of them, so just take a deep breath, and we're going to take our time when we do these. It is important that we do them correctly, okay? I'm going, if it'll let me, I'm going to scroll down. Now this one, I did this on purpose. I told you some of our matrices would just be numeric and some could be algebraic. Now these are algebraic. Now I'm going to tell you right now, first thing we're going to check is, can I even do this, or do I just get to write undefined, okay? This is 3 rows, 2 columns. This is a 3 by 2. Ooh, 3 rows, 2 columns. Yes, I'm going to have to do it. And I'm going to add it. But the thing is, we know what like terms are. Like terms are variables with their exponents exactly alike, or they're just plain numbers. Either way, okay? So this negative 5x plus y squared. Well, I got a negative 5x and I got a y squared. Those are not like terms. So my first entry is going to be very easy because I just have a negative 5x plus y squared. That's as good as I can do it. I'm doing bad on those plus signs. Plus y squared. So that's as good as that one gets because I don't have any terms that I can add together. Now here, I have y minus 3 plus a negative 4. So I've got y minus 3 plus a negative 4. Well, these two terms, negative 3 and a negative 4, are the same. So I can put those together. So I get y minus 7 because a negative 3 plus a negative 4 is a negative 7. So my second entry is y minus 7. And you can see my work over at the side. Okay, nice, neat, and pretty, and easy to follow. I have 1y plus 3 more y's. Well, that gives me 4 total y's because the coefficient of this y is an understood 1. I have 2y plus y squared. Y is not the same as y squared, so there's nothing that I can put together there. So I have 2y plus y squared. That's as good as I can do it, okay? A negative 2x plus x plus 6. Oh, okay, I've got some like terms. I got a negative 2x plus x plus 6 more. Okay, well, these two terms, negative 2x's plus 1 more x, will give me a negative x and then plus 6. Because if I owe somebody 2x's and I give them an x, well, then I still owe them an x. Okay, so a negative x plus 6. So I'm going to put this one down here, negative x plus 6 more. Okay, now a negative x plus y squared. Negative x and y squared, they don't go together, so they're not like terms. So I have a negative x plus y squared. Okay, we won't have the majority of these. I will throw 1 or 2 in there, but again, nothing to panic about. We know what like terms are. We're going to take it slow and steady. Okay, I believe that is it, and it is. So I do want to go back, and we're going to reiterate, okay? We will use matrices to organize and represent data. We're going to create our own matrices later. We'll create matrices to solve systems of equations. So we will learn to organize data there, okay? We will identify the dimensions. We've already done that. Identify the dimensions and the elements of a matrix. I will add and subtract matrices. I will multiply matrices by a scalar multiple. So we've done all that. The only thing that we haven't done is organize and represent data and create systems to solve. But we will do both of these, but in time it's probably going to be about 2 lessons. So not this one, maybe the next one. We'll see how this one goes, okay? So, you know, we've got the bulk of it, identifying the dimensions and elements of a matrix, because if we can't identify the dimensions and elements of a matrix, then how can we create one? If we can't even identify it, we have to be able to identify what a matrix is supposed to be before we can ever create one. okay? We will add and subtract matrices, and we will multiply by scalar multiple. And again, I want to reiterate, to create matrices and to solve systems of equations, well, you don't have to. Let me just back up the truck. You do not have to have a graphing calculator. You do not have to have a calculator that does matrices, but your life will be so much easier. Whereas if you do not have a calculator where we will create matrices, we will organize and represent data, it's going to take us quite a while to solve the matrix system, because lately we've been solving systems with just two variables, x and y, but pretty soon we're going to get 3 variables, maybe even more. So it is important that you do be able to have a graphing calculator. Keep in mind, Mu Alpha Theta does rent them. The rental agreement is available on your stream on your Google Classroom.